All right, so here we have a pot of coffee that cools down and the temperature is modeled in this table according to these time minutes. And so part A, let's evaluate this integral from 0 to 12 of c prime of t dt and explain the meaning of your answer in the context of the problem using the correct units. All right, so since we're gonna take the integral of the derivative of c of t, this is actually pretty simple because remember that we want to basically get the antiderivative of c prime of t, which is just going to be c of t. So this is just going to be equal to c of 12 minus c of 0. And we have those values here. C of 12 is 40, and c of 0 is 65. And so we get negative 25. And so what this means is that, the temperature of the pot of coffee cooled down by 25 degrees Celsius from time 0 to 12th minute. Temperature decreased by 25 degrees Celsius. T equals 0. T equals 12. Okay, part B. Using the correct units, explain the meaning of 1/12 times integral of c of t dt from 0 to 12 in the context of this problem. When you make sense of this, and we're going to use a trapezoidal sum with 5 subintervals indicated by this table to approximate it. Okay, so let's review like what using the trapezoidal sum rule means. It essentially is just a geometric representation for calculating the area of an integral. So let me just draw like a little picture of what this could look like. So we want to find like the integral from 0 to 12, but we don't have an explicit function. What we could do is we take an approximation by making trapezoids. So we're going to have at 0, at 3, at 5, at 7, 8, and 12. This is not drawn to scale, but these are the t values. And c of t are basically the heights of these trapezoids. So we have 65, 57. So over here, that'll be 65. And over here, that'll have a height of 57 when t is 3, 50 when t is 5, 46 when t is 7, and then 44 when t is 8, and 40 when t is 12. So if we were to draw vertical line segments and connect the tops of these points, you can essentially see that you're basically getting trapezoids. You're getting, one trapezoid here, we'll call it A1, another one here, A2, A3, A4, and then A5. So this is pretty intuitive. You're basically just trying to figure out the areas of these 5 trapezoids and adding them all up. And essentially, remember, the area of a trapezoid is the average of the bases. So B1 plus B2 over 2 times the height. So now the heights are just the side lengths or the y values. And then the bases are the y values and the heights are these values here. Anyways, so when you're trying to figure out the sum of each of these, you're just going to take the area for A1. That would be right over here. $65 plus 57 over 2. Times this length, which is 3. Plus this height and this height, or this value and this value, 57 and 50 times 2. Then 50 and 46 for these two bases, 46 and 44, and then 44 and 40. Actually, let me just highlight this here. So like, 0 to 3, 3, 3 to 5, 2, 5 to 7, another 2, 7 to 8, 1, and 8 to 12, 4. And so setting this all up, it's going to look like this. 57 and 50. Times 2. A3 will be 50 plus 46 over 2 times 2. A4 will be 46 and 44 46 and 44 times 1. That's what this is. And then the last one will be 44 and 40. Times 4. When you add all these together and simplify them, you're going to get 599. Now 599 is the total area from 0 to 12. But remember, we're going to take this value and multiply it by 1/12. So 1/12 times 599 and we have about 49.92-ish. Now, what does this mean? This is just this number just represents the average temperature over this average temperature per minute over this time period. Because since there's 12 minutes from 0 to 12, dividing this quantity by 12 is going to give you the average value of C per minute. That's all there is to it. Is approximately 49.92 degrees Celsius. All right, part C, use the data in the table to approximate the rate at which the temperature is changing at time t equals 4. So t equals 4 is between 3 and 5. So since we don't have, 4 as an explicit value, we're just going to basically take the rate of change from 3 to 5, and that'll give us an approximation of the rate of change at t equals 4. So essentially we'll set this up as we'll write c prime of 4 is approximately c of 5 minus c of 3 over 5 minus 3. So 50 minus 57 over 2, which is just negative 3.5. And since we're talking about degrees Celsius, negative 3.5 degrees Celsius per minute will be our answer. All right, part D for t between 12 and 15, the rate of cooling is modeled by c prime of t, which is equal to negative 2 times the cosine of 0.5 t. Based on this model, what is the temperature of the coffee at the time t equals 15? Assume that c of t is continuous at t equals 12. Okay, so we want to figure out what the temperature of the coffee is at t equals 15. We can simply set up an integral with c prime of t from 12 to t because we're told that this is a continuous function on this interval. So what I mean is that we have like this integral from 12 to 15 c prime of t dt. Now the reason I'm doing this is because if you were going to integrate this, even if you don't know the explicit function for c of t, we can still write this as being equal to as c of 15 minus c of 12. Now, if we want to find what the temperature of the coffee is at time t equals 15, we're essentially solving for c of 15, so we're going to add c of 12 to both sides. So we would get c of 15 is equal to c of 12 plus this integral from 12 to 15 of c prime of t dt. Now, why do I do this? Well, because this problem, you got to use a calculator. And we can simply use our calculator to integrate this expression and find what this value will be. So let's go ahead and do that. We're going to use we're going to go to menu, we're going to go to calculus, we'll find the numerical integral. We're going to go from 12 to 15, entering our function carefully. So negative 2 times the cosine of 0.5t. X instead, dx. And we're going to get on negative 4.8966, blah, blah, blah. Now that gives us this value. Let me go, let's write this. C of 15 will be C of 12. We're given C of 12 in the problem as 40. We have this is going to be equal to 40 plus this crazy number. This plus 40, and we'll get our answer, 35.13. about 35.13 degrees Celsius. And that's all there is to it.